Bismillahirrahmanirrahim. Good morning, dear students. In our previous lecture, we started to learn about the language translator softwares. We looked into the compiler and interpreter and assembler. We also discussed about some of the tools that go with the language translator package. There were linkers and loaders and debuggers. Today, we are going to look at the translation process of a compiler. The translation compiler actually goes through 6 phases. The code is scanned, the words are made, their meanings are decided, and then a code is started to build up, and then the code is generated, optimized into its most efficient form, and that's how compiler actually finishes its process. There are 3 data structures that are made, 3 auxiliary components, which are table of literals, symbol table, and error handler. So we are going to look at each of these phases and this data structure of symbol table in detail in the coming slides. The context of a compiler can be explained with the help of this diagram. A programmer is fed into the compiler, and then the preprocessor has to work first. In my previous lecture, I talked about that the preprocessors are actually the commands that are telling the compiler how to process a code. These are the commands which are including the library files of the built-in functions that has been used in our program. And then the source code actually passes through compiler, which actually generates an assembly language code, and after getting through the assembler, the machine code is generated. Linker and loaders finally prepare the executable machine code, which is then can be run on any microprocessor. Now let's look at the stages of the translation of a compiler. We have already discussed assembler and loaders and link editors in the previous lecture. You can pause the video here and read the slide, or you can go back and watch the previous video first. In the phase of compiler design, what we have is actually a front-end analysis or the back-end stages. The front-end phases of compiler actually are usually analysis stages, and the back-end stages are synthesis stages where the code is prepared and optimized and the final executable file is generated. The whole process of the compiler is actually divided into the sub-processes. This diagram actually shows the flow of a compiler's translation process. The first 3, the lexical analysis, the syntax analysis, and the semantic analysis, are the are the analysis stages of the compiler's design, where the code is scanned, analyzed, and then starts with the intermediate code generation and the code optimization, and the executable file is generated, and all these stages are actually the synthesis stages. The first 3 can be considered as the front end, and the last 3 can be considered as a back-end stages of the compiler's translation process. A special data structure called uh, symbol table is also made during the compilation process. We will go through that. How is it made and what's the use of that? If an error has occurred, as you can see from this diagram, that the output of one stage is input of the next stage. If an error is generated at any stage, the compiler actually prepares an error report of the whole code, and then it stops at the analysis stage and then present the user, the programmer, with that error report, and then the programmer has to rectify these errors if they are syntax error or some logical errors or semantic errors, and then the synthesis stages of code generation can be started. So first one, we have to analyze, and analysis is divided into three different phases, and then we are making the code, and the code making is also divided into three stages. The first stage is the lexical analysis. The lexical analyzer is responsible of actually reading the characters and making them into meaningful streams of words. It actually helps the program to realize that which set of words means what. A lexeme is a basic unit of a language. So lexical analyzer actually scans the character and make up words of those characters. And then for each word, for each lexeme, it produces a token. And that token consists of the token name and the attribute value. The token name is the symbol which is going to represent the lexeme. Maybe it's a variable, maybe it's a constant. And the attribute value is going to point to the place of the word in the symbol table. We're going to scan the program, divide them into words, and then we are going to give each word a number for which we can easily reference that word, that what that word actually meant. Look at this example. The simple program statement was written new val equals old val plus 12. Now the lexical analyzer would start analyzing that NEWVAL, and it would make up a word of it. Then that word has to go into some category. So that new val will be categorized as an identifier. You remember that from your early programming lessons that an identifier can be a variable, or also it can be a constant. The symbolic name of something is an identifier. Then it is going to scan this OLGVAL and also consider that it's going to be an identifier. The assignment symbol, the sign of equality, will be scanned and it will be put into the category of assignment operator. Plus is going to be scanned and it will be put into the category of addition operator. Then 12 will be scanned and that is going to be put into the category of number. So here you can see that the lexical analyzer has actually scanned the programming statement, and by analyzing the character it has actually made up words out of them, words, or what we can call them lexeme here, and then it has categorized each of that lexeme into its relevant category of identifier or an operator or maybe a number or a constant, And this thing is called tokens. This process is called tokenizing. So lexical analyzer also truncates the white spaces and remove if you have any errors. If there is a syntax error here, the lexical analyzer cannot read the word. You may have used, you may have tried to use a reserved word, like you have tried to use if as a variable name. The lexical analyzer will point out the error here. It's going to recognize all the characters that are there in the character set of a programming language. Remember that character set of a programming language are all the characters which are valid to be used in a programming language. So the lexical analyzer is going to read all the words and make up the categories of all the words. This is another example of the analysis of a lexical analysis. The output is written there. You can see that identifiers and white spaces and the punctuations and the identifiers and strings, if there are any strings, they are all separated into different categories. So this is what actually lexical analyzer do. In the next stage, we have the syntax analyzer, also called parser. Now, the parser actually uses the components of the token produced by lexical analyzer to create a tree-like representation. That syntax tree actually helps us make the syntax sense of the program statement. For example, consider your calculators for a moment. Your calculators actually ask you to input a value first, then press an operator, and then add another value. And then you can get your answer, right? What the syntax is actually asking you to do is input a value, then an operator, then another value. Another type of calculator may also ask you to first enter a value, press the enter key, then enter another value, press the enter key, and then enter the operator. And then you will be given the output. So while the lexical analyzer can only recognize these words as variables and operators and assignment operator, the syntax analyzer is supposed to check whether the written statements were in correct order of syntax or not. So this is the duty of syntax analyzer, to check for any syntax error if there are any. For that, it actually establishes a syntax tree. Consider this example: the new val equals old val plus number. Okay, what is going to happen here is we are going to make a syntax tree diagram here. Basically, this sign of equality here is the center of our syntax tree. So it's actually an assignment statement. And then this assignment statement is having one variable new val as a children node, as a child node, sorry. And then on the other hand, it's having another expression. Now see that since it is, this side has the plus in it, the programming language is going to consider that as an expression. And this side only has a single variable. So it's going to consider that a single variable, an identifier is there, and that identifier is placed on the left side of the assignment operator. However, on the right side of assignment operator, the tree is extending. There's a plus sign, and then on the left side and the right side, we are having the expressions which are being connected with the plus sign. And look at this detail, that the output of lexical analysis is actually being used to make the syntax trees here. Now this is how the syntax analyzer is going to make sure that all the values are actually in correct syntax form. All the values or all the programming statements and expressions that are written, they are actually following the correct way of syntax. Again, the syntax, just like I showed you the calculator example, the syntax can be different. The syntax can be different for every language. So the syntax trees made are also going to be different according to the syntax of that language. This is just here to give you the concept of how syntax trees can be made. After we have made the words in lexical analysis stage, and after we have established that the words are in correct syntax at the syntax analysis stage, what we are going to do, we are going to decide what they mean, the semantic analyzer. Now the semantic analyzer actually decides what the program statement actually means, what the program is trying to do. Remember that a program can be syntactically correct. A program statement can be correct according to the syntax, but it can be incorrect according to the semantics of the programming language. The word semantic actually just means the meaning of the purpose of the programming language or the programming statement. What the programming statement is trying to say, or what the programming statement is trying to do. The meaning or the purpose of the programming statement would be decided here. If you have used multiple types of variable in one programming expression, the types will be checked here. If you are trying to store an a character value or a string value into an integer variable, this is where the error is going to be checked. That variable is integer and the input value you're trying to enter is string. So this is where the error is going to be checked, and the user or programmer will be intimated that they are trying to enter wrong value into a wrong variable. So we have done the floating point and fixed point conversions as well, and we have also dealt with some of the errors, like for example, if you're using an array of 5 values and we try to access the index of that array, the sixth index of that array, it's going to give an error. For example, if I say dim num5 as integer, and then what I try to do, I try to write num7 and then I assign it some value, whatever. That is actually going to give us an error. Remember that you have done this using a for loop, and then what you try to do, what you try to do is that you try to store some value in the array. For the simplicity of my example, I'm going to store 65 in all the elements of my array. And next, what's going to happen here is that we are going to face an error that index is out of bound, out of range, and the program will crash eventually. This program will not give you a syntax error at any stage, but the semantics of this program is wrong. The meaning of the program is incorrect. What the program is trying to do here is not okay, because the program is trying to actually store a value at a place which does not exist. The maximum subscript value of the num array was 5. We are actually trying to access the subscript 6 and 7 as well, which does not exist in the number array. This type of things are actually going to be checked at the semantic analysis. So again, the semantics analysis actually try to determine what the program statement means, what it is trying to do, and is it logically correct or not. So semantic analysis actually checks for syntactically correct but semantically incorrect errors. Another example is here, where your example is sum is equal to a plus b. And if you make uh, a as an integer, b as a character, and sum as a double, the data type mismatch error will occur. Because although an integer and double both are numeric data types, the character data type of b is going to cause an error. This is how actually semantic analysis checks for the errors and intimate the user if there is any problem or error. The last phase of the front end analysis, intermediate code generation. We have done the lexical analysis, the syntax analysis, the semantic analysis, and the end stage of compiler is going to actually end at the fourth stage, which is intermediate code generation. Now, this is where I want to remind you of questions, the type of question that you might have faced in your O-level exams, that you are given a piece of code and you are asked to make that code short, write a better code than that. So what you do, you actually try to find a way of doing the same thing in less number of statements. That's called actually code optimization. We'll get to that in the next part of the lecture as we start for the backend analysis. But the first draft of the code is going to be generated at the intermediate code generation stage. After syntax and semantic analysis are done, the intermediate code or the first draft of the code would be generated, and that actually intermediate form called three address code, which consists of a sequence of assembly like instruction with three operands per instruction. Each of the operands here can act like a register. They can store values of input and also can present the output. This is the phase which is going to bridge the analysis and synthesis stages of translation. Synthesis stage is where the code is generated, where the executable file is going to be made at the end. And the analysis stage is what we have actually studied up till now. So this would be an example. We have a program statement like new variable, new val equals old val plus factorial of 1. So you can say that that fact is also a variable, not a factorial. Actually, just ignore that factorial word, just a force of habit. So you have identifier 1, 2, and 3 as variables, and you have number as 1. So we would create temporary memory locations where we would store those identifiers, and solving binary operations one at a time, we can finally make the output in one of the variable temp3, and that can be assigned then to our identifier 1. This is what I meant in the previous slide, that these operands can act as the register. They can store and they can process the values temporarily. That's all for this. And in our next part of the lecture, we are going to study the backend stage of the translation process, the code optimization, and the code generation and symbol table management. See you on Monday. Have a good weekend. Allah Hafiz.